All right, guys, are there any questions on any of the assignments thus far? All right, guys, if there's no questions on any of the assignments, we're going to go on and get started on the lesson today. And what we're talking about today is special right triangles. We're going to be talking about special right triangles. And the one we're looking at specifically is the 45, 45, 90 special right triangle. In this triangle here, is going to be an isosceles triangle, because we know that the sides opposite congruent angles are congruent. So in a 45, 45, 90 degree right triangle, the two sides opposite the 45 degrees are going to be the same. And incidentally, it does work out that the hypotenuse is going to be that value, square root of 2. And by our theorem here for a 45, 45, 90 right triangle, thank you, you can put that on my desk. The triangle, the hypotenuse is the square root of times as long as each leg. So the two legs are the sides that are opposite the 45 degrees. These two sides here are considered to be the legs of the triangle, and the hypotenuse, the side opposite the 45 degrees, is whatever that value is times the square root of 2. So let's look at the first example of these 45, 45, 90 right triangles. Now when we look at this here, we do have a 90, 45. Well, this other angle here is 45. Because all three angles are going to add together to be 180, and if one of them's 90 and one of them's 45, well, the other has to be 45. So, guys, we know that the sides opposite the 45 degrees are going to be the same, because the sides opposite congruent angles are congruent. So that tells us that these two sides have to both be the same. They're both going to be 8. Which means we still need to find the value of x. Well, to find the hypotenuse, we can use the Pythagorean theorem that we went over yesterday. A squared plus b squared is equal to c squared. The hypotenuse for us is going to be the missing measure x. So for c, we can replace it with x squared. Now the legs a and b are both going to be what? 8 squared plus 8 squared. Now we can solve this to find out what the hypotenuse is. Now at this point here, we can plug 8 squared plus 8 squared into the calculator. Because it would be 64 plus 64, which is 128. Now, like we did this yesterday, to get x by itself, we have to take the square root of both sides. And the square root of x squared works out to be x. And the square root of 128 is 8 square root of 2.
So how could you turn that into just a regular old number?
The button above enter, the approximation. But we're going to leave all these with the square root because it does work out to be the same. Because if we look back at the theorem, in a 45, 45, 90 right triangle, the hypotenuse is the square root of 2 times as long as each leg. So what did we get here? Well, we got the two legs are both 8, and the hypotenuse is what?
8.
Square root of?
So is it always going to be the same associated with?
It's always going to work out in that exact way.
Like, so if it was 10 instead of 8, on both of those, it'd be 10 squared.
So let's look at this one here. So we see, well, this angle over here is 45.
Y is going to be 19.
Y is 19. Because the sides opposite the 45-degree angles are the same. So since 19 is opposite this 45 degrees, it means that this side also has to be 19. Now we still need to find the value of x, the hypotenuse. Now we can use the Pythagorean theorem to find this. Well, our a squared plus b squared equals c squared. Well, the value of a and b are our two legs, which would be 19 squared plus 19 squared. And exactly, if we type this into the calculator, we would get 722 is equal to x squared, our hypotenuse. And if we square root both sides, square root of x squared is x, and square root of 722 is 1. Questions on this so far? So is it still holding true that the hypotenuse is the length of the leg times square root of 2? Well, yes. So if we look at the next one here, well, this time they gave us the hypotenuse, which is? And but we can work this out. Now, we know that the side lengths opposite the 45 degrees are going to be the same. So if we wanted to, and what we'll look at this here is the Pythagorean theorem, a squared plus b squared is equal to c squared. Since a and b are the same, well, we can say that x squared plus x squared is equal to
x squared
9 squared root of 2 squared, because those two side lengths are the exact same. And the hypotenuse is our 9 square root of 2. And if we plug this in, well, x squared plus x squared, we can't type in the calculator because they're variables. But if we add them together, we have how many of them? 2. So we'd have 2x squared is equal to. Now we can plug 9 square root of 2 squared into the calculator. And if we do this, we need to make sure we put parentheses around it so that it's not just squaring the square root of 2, but it's also squaring the 9. And if we type this in, we get, or should get, 162. Any questions on this here? Then what do we need to do next in solving this here? Well, we need to get the x squared by itself, so we would divide both sides by 2, which tells us that x squared is equal to and last but not least, we would square root both sides And the square root of x squared is?
X.
And the square root of 81 is? So our two side lengths are? In a little bit. Any questions on this here? All right, let's look at this one here. Now this one here, we want to find the values of x and y. Now again, with a 45, 45, 90 right triangle, we know that the values opposite the 45 degrees, the sides opposite the 45 degrees are going to be the same. So the value of y has to be. So in any 45, 45, 90 right triangle, two of the sides are always going to be the same. And it'll be the sides that are opposite the 45. Now we need to find the value of x. And how do we get there? Because it is the same as the last one. But if we look back to our theorem here, in a 45, 45, 90 right triangle, the hypotenuse is square root of 2 times as long as each leg. So if we know that the leg, so leg times square root of 2, well, what's the length of the leg? 9 times square root of 2 is 9 square root of. And we could use the Pythagorean theorem to find it just as easily. Because we could set this up as 9 squared plus 9 squared is equal to our x squared. 9 squared plus 9 squared is 162. Nice. And we take the square root of both sides. Tyler, let's sit over there. We get that x is equal to 9 square root of 2. Any questions on this here? Let's look at this one here. Now we know that x and y are going to be the same. Yes? And why are you saying 11?
Because that one's 11. They're always opposite.
So x and y are always going to be the same because they're opposite the 45.
And that one over there, that end is also going to be 45.
So we're saying x and y are both 11. Because we know the hypotenuse is going to be the length of the leg times the square root of 2. Now we can also look at this using the Pythagorean theorem. A squared plus b squared equals c squared. Well, a and b, the two side lengths are both the same. And since we don't know them, we can call them both x. So x squared plus x squared is equal to 11 square root of 2 squared. Now our x squared plus x squared is going to be 2x squared. And 11 square root of 2 squared is 121. I believe it should be 242. And what would we do next? We would?
Divide by 2 on both sides.
Telling us that x squared is equal to
121.
And the square root of 121 is? So the two side lengths are 11 and 11. Any questions on this here? Well, I want to look at this again. What did we say the hypotenuse is? It's the leg times the square root of 2. Well, if we call the leg x, we're saying that that leg's length times the square root of 2 for this problem here would equal what? Because the leg times the square root of 2 is equal to the hypotenuse. So for here, it's equal to 11 square root of 2. Now we want to find what? We want to find the value of? Well, if I want to get x by itself, what would we need to do? Well, it's being multiplied by what? It's being multiplied by the, well, to get rid of it, I would have to. Because anything divided by itself is 1. And what's 11 square root of 2 divided by the square root of 2? Because anything divided by itself is 1, which would leave us with any questions on this here? So we're saying both u and v are, because we know that the hypotenuse is equal to the length of the leg times the square root of 2. Length of the leg times the square root of 2 will be our hypotenuse. Well, do we know what the length of the leg is? Well, we know it should be 12, yes? But if I'm solving for it, well, we can call it x times the square root of 2, because they didn't officially give us it. We were able to figure it out. And they told us that the hypotenuse is what? 12 square root of 2. Well, one way we can go about finding it is using this here, dividing both sides by the square root of 2. Well, these will cancel out, telling us x is equal to 12, because these will cancel out also. Questions on this here? Are you ready for the next one? So we know that the two sides opposite the 45-degree angles are going to be the same, yes? And the hypotenuse is the length of the leg times the square root of 2, yes? So let's go about this using the Pythagorean theorem, because this does seem like it's going to be completely different than what we've been doing before, yes? The last few. So if we set this up, well, I know that these two lengths are going to be the same. So a and b are still going to be x squared and x squared. The hypotenuse is 12. So we'd have 12 squared. Well, our x squared plus x squared, as we've seen several times ago, is going to be 2x squared. 12 squared is 144. Now we would divide both sides by 2, which will tell us that x squared is equal to 72. And last but not least, we need to what? Square root both sides. Divide it by 2 and what? Because if we just divide 12 by 2, we would get 6. Okay. Yes. And let's look at that now. Is everybody good with writing this here? Because I'm going to erase this. So, Jake, what you're saying is that you took what, 12? And
divided it by square root of 2.
And we could actually type that into the calculator. And it would give us 6 square root of 2. Now, the way that the calculator actually gets to this is it's multiplying, and it's going to rationalize the denominator. Because we can't have a radical inside the denominator. We can't have a radical or a square root in the bottom of a fraction. Now, if I multiply the square root of 2 by the square root of 2, well, we multiply the numbers inside. Well, 2 times 2 is square root of 4. Well, the numerator for this here is square root of 2 as well. Because we do square root of 2 over the square root of 2, because we know that anything divided by itself is what? 1. So really, we're multiplying this fraction by 1. So it's not going to change it. Now the numerator becomes 12 square root of... Well, what is the square root of 4? 2. Well, 12 divided by 2 is what? So we get 6 square root of... So the two legs here are 6 square root of 2 and 6 square root of 2. Now, we said that the hypotenuse is the leg times the square root of 2, yes? So what is the leg's value? 6. And if we multiply it by the square root of 2, we should get the hypotenuse. So, well, the square root of 2 times the square root of 2 is the square root of 4, which is? So even though we didn't have a square root of 2 with the hypotenuse, do the properties still hold true? Yeah. So even though there's not a square root of 2 here, well, there's ones over here. So almost like we did with the previous one here, and as Jake walked us through, leg times the square root of 2 is equal to our hypotenuse. Well, exactly, we did x squared root of 2 is equal to, well, we divided both sides by square root of 2, which told us x is equal to 6 square root of 2. So here we want to find the values of u and v. 5 square root of 2 for both, yes. Because how do we get to that? Well, essentially we're saying that x times the square root of 2, we would divide 10 by the square root of 2, because these will cancel. And 10 divided by the square root of 2 is? So that would be the length of the two legs. Questions on this here? What do we think about these here so far? And no matter what the numbers are, this will work. Are you ready for the next one? This would be, well, we don't use decimals because decimals and radicals don't go together. So we can look at it, not leg, x squared root of 2, the leg times the square root of 2 should equal what? 11. So, like we've been doing, we've really been dividing the hypotenuse by the square root of 2. These here will cancel. Well, if we type in 11 divided by the square root of 2, we get what? 11 square root of 2 over 2. Unfortunately, they won't because of the radical. So this is actually x and y. Now, I think what you're trying to hit at is why did it simplify out before, yes?
It was 11 on here.
Let me see.
Actually, I just did that.
Now, why did this one not simplify down to just a number when the previous two did?
Said it can't because of the.
Well, why did this one simplify down? Because the hypotenuse here is even, because 10 is divisible by 2, yes? And the one before was 12. 12 is divisible by. So if we look at the one we just did, well, the hypotenuse is 11. It's an odd number, so it can't divide by 2. So the denominator of 2 has to stay. It looks more complicated, but did what we do really change? No, it's the exact same. And in the end, this is always, the hypotenuse is going to be the leg times the square root of 2 on every single one of these, no matter what we have. We ready to look at the last one we're going to look at today? Now, we said the hypotenuse is what? The leg times the square root of 2, yes? So whatever the leg's length is, if we multiply it by the square root of 2, we should get what? So the leg's length, because they're both the same, times the square root of 2 should give us 3 square root of 5, yes? And on all the ones leading up to this here, what did we do? Well, we divided both sides, sorry, yes, thank you. Both sides by the square root of 2. Yes. And the value of y here is going to be 3 square root of 10 over 2. And they're going to be the exact same. Any questions on this here? Now, this is still holding true. Even though the numbers look weird, it's still the exact same thing. Because the legs of a 45-40 right triangle are going to be congruent. And the hypotenuse's length is going to be whatever the length of the leg is times square root of 2. So, oh, let me erase. Because what we said the legs are is 3 square root of 10 over 2. Well, if we multiply it by the square root of 2, we should get back to 3 square root of 5. Now, if we multiply these together, well, the square root of 2 and the square root of 10 will multiply because we multiply with the numerators. And 2 times 10 would give us 20. Well, the square root of 20 is, we can break it up to being 4 times 5. Now, the square root of 4 is 2, but we can't take the square root of 5. Well, 2 divided by 2 is 1. That would simplify to 1, leaving us with what? 3, which is our hypotenuse. Because again, the hypotenuse is the length of the leg times square root of 2. As we were able to show here, got 3 square root of 10, the length of the leg. Well, it's going to do this again. The length of the leg times the square root of 2 does get us back to 3 square root of 5. So even though the numbers changed and look a little weird, did the actual process and anything we did actually change? No, because it's still the exact same thing. Now,